Scratch paper here so I can take some notes while I read it. My scratch paper's looking a little messy. Let me see what I got here. There we go. You'll never know how much paper I have just around my desk, but out of sight. Okay, so if you begin with 3.94 grams of hydrogen, and 57.79 grams of oxygen, where oxygen is the name of O2, how many grams of H2O can be formed? Now, this is a limiting reactant problem. That's what LR stands for. And, oh, I forgot to write the balanced reaction. And you'll get balanced reactions for this type of problem. Oh, I went ahead and did another problem anyway. Let's go ahead and do this one, and then we'll take a break. I get carried away sometimes and excited. So, and I went over this in the lecture notes, or the lecture outlines. So anytime you have enough information about two of the reactants to find moles, that means it's going to be a limiting reactant problem. And you're going to do 50 at least limiting reactant problems in various forms throughout this course. Maybe even 100, but I promise you 50. When you do a limiting reactant problem, you always, or there are a number of ways to do them. The way that I do them is you do two sets of calculations. You first start with the grams of hydrogen, and you do a picket fence or unit conversion style problem. You also start with the oxygen, and when you get to the other side, then you calculate grams of H2O. Whichever number of grams of H2O is smaller is the actual amount you can form. Or produce via this reaction. And it does so it doesn't necessarily mean which one of the reactant amounts is smaller. And what you'll see when you work this problem, and if you talk to your classmates, that everybody has different grams for each of these, and that the limiting reactant will change depending upon which grams you use. But then from here, it's just like the last problem, except twice. So take your grams of hydrogen, do the molar mass, where 2 hydrogens are 2.016 grams. And then in this reaction, the mole to mole ratio requires that there be 2 moles of hydrogen for every 2 moles of H2O. And for H2O, and you'll note that the molar masses here always have 1 mole of H2O, or 1 mole of each substance. The numbers here can be whatever are the coefficients in the balanced reaction. 1 mole of H2O, I've done this before, 18.02 grams H2O. And we'll do this calculation in a minute to get the answer for this part. Down here for oxygen, it's actually 32.00 grams of oxygen for 1 mole. And then for oxygen, it's 1 mole of O2 for every 2 moles of H2O. And then the last step's the same. And some students just stop here, find the mole answer, and then only do the last gram part once. But this is the way I do it. This is the way I've memorized it, and I think and makes sense to me, which is where you need to be. All right, so let's do the math for this top part. Just thinking about this. So 3 times 20 is about 60. 60 divided by 2 is 30. And these two 2's cancel each other out. So I'm expecting it about somewhere around 30 grams. Let's see what we get. 3.94 divided by 2.016. I'm skipping these two because they cancel. Times 18.02. 35, that's pretty close to 30. At least I know my calculation's roughly in the right ballpark. I get 35.2 grams here. Down below, and again, we don't know if that's the amount we can make yet, but let's figure it out. Here, 57.79 divided by 32. This time I do have to do this, times 2 times 18.02. And here I get 65.1 grams. And this time I can only make 35.2 grams H2O. It is the smaller amount, and that is how it's only ever the smaller amount, and it's never the sum of them. It's this. So can be produced. And this question didn't ask it, but if it did, H2 is the limiting reactant. Any questions about any of the work you see? If not, we'll go and try and enter it in here. 35.2 grams. And there's no way for you to enter units. I thought about it, but 35.2. And sure enough, 35.2 is the grams that you get. All right, that was homework 0209.